Recording. Okay, so we have a test on Friday, so please make sure you're getting things together for it. Like I said, you have a review. It's due on Thursday of this week, and you just do a little bit each time, okay? Now today I really need you to keep focused. Today is a lot of abstract, vague stuff. It's like learning how to play a game when someone's going through all the rules with you, and you're like, I don't really know what you're talking about. But when you sit down to play the game, you go, oh, now I get it. That's tomorrow. The oh, I get it happens tomorrow. Okay? Today, we're going to teach you the rules of the game. It's not very exciting, and it's a little abstract, and you might be going, I have no idea what she's talking about, but when we apply it tomorrow, it'll all make sense. Okay? I've not lost anyone yet, so I know this is going to happen. Okay? So, let's get our notes here. Start our notes. Okay. Now, when we were talking about the atom, we'll get back to the history of the atom here in a few minutes, but we were talking about Bohr and Bohr's diagrams and how Bohr thought the atom had a nucleus where, what's in the nucleus again? Protons and neutrons. Good. So if I want to draw a Bohr diagram for, let's say, silicon, what's the first thing I do? Hello? Thank you. So what's the first thing I do to draw my Bohr diagram? Put my protons in the nucleus. Good. How many go in the nucleus? 14. So 14 protons go in the nucleus. And then what do I do? The semicircles. How many go in the first energy level? 2. Second energy level? And third energy level? Up to 8, but do I really need 8? No, only 4. So I have 14 electrons here and 14 protons. That's a Bohr diagram. So Bohr showed us energy levels around the nucleus where these electrons were to stay, and they had just a certain amount of energy for each level. That was Bohr's idea. But it wasn't right. He got us where we needed to be, but it's not correct. His idea is not correct. This is the model we're used to looking at now. This is what we think to be true. It's called a quantum mechanical model, or a wave mechanical model. Okay, it shows us a wave-like pattern. Okay, so far so good. Yes? Okay, now we know, based on Bohr's diagrams, that 2 electrons are in the first energy level, correct? We know that 8 are in the second energy level. Here's where he messed up. There's 18 in the third, not 8. They came up with a calculation of 2n squared. That's how we figure out how many electrons are in the energy level. So the first energy level here, 1 squared, so 1 times 2 gives me 2 electrons. 2 squared is 4. That's how I get 8 electrons. The third energy level, 3 squared is 9 times 2 gives me 18. How many would be in the fourth energy level? 32. Because 4 squared is 16 times 2 is 32. That's how we determine how many electrons are in the energy levels. Okay? Okay. Now, this guy named Heisenberg came along, and he came up with this thing called the uncertainty principle. He said there is no way to know the momentum and the location of an object at the same time. You just can't know it. especially something as small as an electron. It's almost like me letting a fruit fly loose in this room and trying to figure out where it is. And I'm like, oh my gosh, it's right there on Sid's head. I go to grab it. What's it going to do? Probably fly away. Most fruit flies fly away, right? So I knew its location, but now I don't know its momentum. You know one or the other, but you can't know both. That's what Heisenberg came up with. It's called his uncertainty principle. And he applied this to the atom to show, really, you don't know where these electrons are. We have, in his mind, atoms weren't even a thing. He's like, we don't know, we will never know exactly where these electrons are. It's just not going to happen. But this next video is going to show you. So if you're home watching, get on your PowerPoint and watch this video. And let me